Okay, the topic for the discussion in this video lecture is about the control architectures used in robotics. And this is Dr. Small Lakshmi, Professor and Head, Department of ECE from Rohini College of Engineering and Technology. And on completion, the student will be able to list out the various type of architectures involved in robotics. They will understand the limitation of the architecture, as well as they'll be able to represent the model of various control architectures. So this is deliberative robo control architectures. So in a deliberative control architecture, the robo first it will plan a solution for the task by reasoning about the outcome of its actions, and then it will execute. So you can see here there is a sensor and actuator. So between this layered structure is there, where it is perception, modeling, planning, then it will execute the task, then finally the control is given to the motor through the actuators. So this is defined or termed to be a deliberative robo control architecture. So the control process goes through a sequence of things, such something like sensing, model updation, and planning these steps. And what are the advantages of this thing, and what will be the problems normally faced? So advantages, there are reasons about contingencies. Computer solutions can be given to the given task, and these are all goal directed strategies. But the problems are like it tend to be fragile in the presence of uncertainty. We need to have a very frequent replanning, and it reacts relatively slowly to changes, and it may even cause unexpected occurrences. And coming to the second type, which is a behavior based robo control architecture. So in a behavior based control architecture, the robo actions are determined by a set of parallel reactive behaviors which will map the sensory input and state to action. So it is very similar to the previous aspect, but you could see here we have various interleaved structures this will find a reason about the behavior of object. It will plan changes to the world, identify, it will monitor the changes, it will build the maps, it will explore, then wanders. So this and all it is done by a sensor. Accordingly, these actions are planned and it is executed through the actuators. And coming to this behavior based control architecture, so here they are relatively very simple behaviors. So each of which achieves a particular subtask to achieve the overall task. So robo can react fast to changes. The system does not depend on complete knowledge of the environment. Emergent behavior. So this results from combining initial behaviors. This could make it difficult to predict exact behavior, and it is difficult to assure that the overall task is achieved. And coming to this complex behavior from simple elements, so it is called as a Breitenberg vehicles. So complex behavior can be achieved using very simple control mechanism. So these are differential drive mobile robots with the two light sensors. So complex external behavior does not necessarily require a complex reasoning mechanism. So you can see here from the figure. So we define here as covert, love, aggressive, then it's a behavior. So as it, of course, we know it is a behavioral aspect. So these are the four types they have defined, and these behavior based architectures are subsumption, so which means one layer will lay on the other one. So this is one of the earliest behavior based architecture. So they are arranged in a strictly priority order, where higher priority behaviors subsume lower priority ones as long as they are not inhibited. So from the level 0 to the level n. So again you have one end you have the sensors to sense all these things, and again this is actuated by the actuators. And this is the subsumption example. So this can be performed in the thing. So this is taken from the MIT University. So the source is there. So if you want, you just play this video and just check it. And this is a reactive behavior based control architectures has of course its own advantages and problems. Their reactions may not be fast to changes, and thus it does not rely on accurate models. The world is its own best model, no need for replanning. But problems are like it will be difficult to anticipate what effect combinations of behaviors will have, and it is difficult to construct strategies to achieve a complex or novel task, and it requires a redesign of control system. Suppose I'm going to give a new task, or the robot has to perform a new task. 1 minute. And the third aspect, third architecture is a hybrid control architectures. So this will have the combination of a reactive control with abstract task planning. So abstract task planning layer, and we have a reactive behavior layer. So this task planning will tell you about the deliberative decisions. It will plan the goal-directed policies. As a reactive behavior layer, it will provide reactive actions. It will handle the sensors and actuators. So you can see here in the behavior set, you have the motors and sensors, and in the abstract task, you have all the behavior activations. And similarly, this also has its own advantages and problems. So advantages, it permits goal-based strategies. It ensures fast reactions to unexpected changes, in unlike in the other two things. And it will reduce the complexity of the planning. But the problem is the choice of behavior will limit the range of possible tasks. Behavior interactions have to be well modeled such that it will be able to form the plans. And this is an example of reinforcement learning in a hybrid architecture. So you have different layers over here, which is a policy acquisition layer, abstract plan layer, reactive behavior layer. So in the policy acquisition layer, you will be learning the task without any supervision. And abstract plan layer, you will be learning a system model. There will be a basic state space compression. And reactive behavior layer, there will be initial competence and reactivity. Thank you.